afternoon, everyone. Thanks so much to Phil for organizing today's session and to everyone for coming, and especially to Andrea and to Elena for sharing their story. That was really inspiring for me. So I work at Silent Spring Institute. I study water quality and have focused on Cape Cod, where we've been looking for emerging contaminants, including fluorinated chemicals. So today I'm going to provide some more background about fluorinated chemicals and talk a little bit about our water quality work. Some of the background information has already been covered in the previous presentation, but saying it again will help reinforce it. So like Phil said, I have a Google alert set up for perfluorinated chemical, PFOS, PFOA. I used to get maybe one thing a month, and it really has picked up just in the last few months where I get at least one notice every day, it seems like. Nick Kristoff from the New York Times covered fluorinated chemicals last year in one of his columns. There's been a small town in upstate New York where public and private wells have been affected by PFOA from a plastics manufacturing facility. It even got covered on The Daily Show. And we've heard a lot about the tragedy in Flint, Michigan with lead, but lead is not the only contaminant of concern in the Flint water system. The Flint River itself also has elevated levels of perfluorinated chemicals. So I wanted to stop for just a moment to talk about terminology, because for now, for this presentation, I will use the term fluorinated chemicals because it's actually easier to say, but they go by many different names. So the previous presentation you heard about PFCs, or perfluorinated chemicals. The chemists say, well, you can't just say perfluorinated, there are polyfluorinated ones. So there's this other term, PFAS, which is per and polyfluoroalkyl substances. So that just rolls off the tongue really easily. And then the Green Science Policy Institute says highly fluorinated chemicals, because that's at least like a phrase that you can say. So these terms all kind of go around. They're like different umbrellas. The perfluorinated chemicals fall under the PFASs. I'm just going to say fluorinated chemicals. They're all kind of the same thing, and if you want to get into which one falls in which category, we'll talk about that. Andrea and Elena talked about PFOS and PFOA. These are the PFCs that we've thought about the most and understand the best. They all have some shared properties. So fluorinated chemicals are an enormous category of chemicals I keep learning about more and more. Some are actual ingredients in products, some are used in the production, some are breakdown products, but they all have some common characteristics. So one is this this long carbon chain in the middle, this backbone, and around it are the fluorinated ones are all completely fluorinated, or they can be partially fluorinated. This end is more oil soluble, and then they have this other end that's more water soluble. And because I've gotten this question before, we're talking about organic chemicals with lots of fluorines as fluorinated chemicals. It's not the same discussion as fluoridated water. Sure, that's like another topic for another day. That's just fluoride by itself. So when did we start having fluorinated chemicals? So both Teflon and Scotchgard were actually discovered by accident around the year 1950. So Teflon was discovered by some scientists at DuPont. They were working on refrigerant gases, and one of their canisters, when they came back the next day, instead of having the gas that they were looking for, it had this white sticky substance, and they quickly realized, wow, it's really slippery, nothing makes it break down, it's really resistant at high temperatures. I bet we can think of some other things to do with it, like put it all over frying pans. So that was the birth of Teflon. And Scotchgard was actually discovered by a woman scientist, there weren't many of them at that time, working at 3M. And one of her assistants spilled this fluoro rubber compound they were working on his shoe, and they discovered they couldn't wash it off. It didn't discolor the shoe, and they said, I bet we can find some other things to do with this. So that was the birth of Scotchgard. And since then, fluorinated chemicals have been incorporated into many common products. So for instance, carpets and upholstery that have Stainmaster or Scotchgard coatings, waterproof apparel with Gore-Tex, certain floor waxes and ski waxes, nonstick cookware that has Teflon, a lot of grease-proof food packaging, so a lot of pizza boxes and microwave popcorn bags, and even certain dental floss. If you really like that thin, ribbony Oral-B Glide, that has Teflon in it. So it's funny that's the one people really So like I said, fluorinated chemicals are a family of chemicals, so each individual compound has its own properties, but they do share some common characteristics. So these are not naturally occurring in the environment. They are extremely persistent. That carbon-fluorine bond is like the strongest bond in nature. So these things just really don't break down, even at high temperatures. So that's why they're used in things like the firefighting foams for treating oil or for fighting hydrocarbon fires. And they have this property of being able to repel oil and water that makes them very useful. So we started using these things in the 1950s, but it really wasn't until the early 2000s when scientists started wondering about their persistence in the environment. And in particular, PFOS, or the structuring ingredient, has been found in wildlife globally. And in general, if you kind of look at where the highest levels are in wildlife, they tend to be in urban areas, which makes sense. It's closer to areas where they're being produced or used. But you also find high levels in polar bears and other Arctic wildlife, where there are no production facilities, no people around. And that's because some fluorinated chemicals are quite volatile, so they can, at lower latitudes, end up in the air, and then they move to the polar regions, and then they essentially condense, I guess, and end up in the water and at the bottom of the food chain. And PFOS in particular has that property where it can biomagnify, so as you look up the food chain, just like PCBs or methylmercury, you tend to see higher levels in the top predator species. So if they're in the environment and they're in wildlife, you can also believe that they will show up in people. So as in the previous presentation indicated, over 99% of Americans have traces of fluorinated chemicals in their blood. And PFOS, PFOA, and PFHXS can remain in the body for years. So again, if you stopped your exposure right now, it would take years to reduce the amount in your body by half. So PFOS and PFOA have been the most studied out of all the fluorinated chemicals in terms of health effects, and there hasn't really been as much research on the other fluorinated chemicals. So studies in laboratory animals have linked PFOS and PFOA to liver, testicular, and pancreatic cancer, to liver enlargement. As a breast cancer organization, we pay particular attention to chemicals that may play a role in breast cancer. So PFOA has been linked to mammary gland tumors in animals and also to altered breast development. And there have been links to toxicity to the immune system and changes in cholesterol. There have been a few epidemiological studies, so directly looking at how exposures in people affect people's health. So two of the most notable examples. So in West Virginia, near a DuPont facility, there was extensive contamination of the water system with high levels of PFOA. There was actually a successful lawsuit that came out of that, and the funding for that funded a science panel called the C8 Science Study Panel. PFOA is also known as C8. And so a lot of what we know about effects of PFOA on people come from that panel. The panel was charged with looking at 55 different health outcomes, and of those, they found that 6 were more probable than not linked to PFOA. So high cholesterol, thyroid disease, testicular and kidney cancer, pregnancy-induced hypertension, and ulcerative colitis. There's also been extensive work by Philippe Grandjean of the Harvard School of Public Health and his colleagues in the Faroe Islands, where the population is exposed through consumption of whale meat. And he has found that there's effects to the immune systems of children, so immunotoxicity. So for instance, vaccines are less effective in children that have the highest levels of the fluorinated chemicals in their blood. And kind of one most concerningly from his work is that he has suggested that those effects happen at levels far below the provisional health advisories that have been developed by EPA. So I know Lauren and Phil are going to talk more about the regulations and sort of what's happened on that side of the production. But I just want to mention that PFOS and PFOA production in the U.S. is being phased out. And so exposures to those two particular PFCs have been going down in the general U.S. population. EPA has developed provisional health guidelines for PFOS and PFOA. So these are not enforced, and public water supplies are not required to test for them all the time. And they were, in fact, developed for short-term exposure, with the provisional part, and not necessarily like a chronic lifetime exposure. And those are in the process of being reevaluated. So what happens if you're not going to use PFOS or PFOA anymore? You're going to put in another PF something, right? So it's the same story with BPA, where we have BPA-free, 5 minutes. BPA-free plastics, and what's in them is BPS or other similar compounds. So we see PFOS exposures are going down in the general population as they're used less frequently, but some of these other perfluorinated chemicals are becoming more common. We have much less information about health effects. They do tend to be less persistent in our bodies, so the half-lives are not on the order of years. They're much shorter, but we're still exposed to them all the time, and we just really don't know what the health effects are. So I mentioned the DuPont facility is one instance where drinking water was highly contaminated by PFCs, and there are other instances, say in Minnesota near the 3M factory as well, where these production facilities are major sources of PFCs into the environment. Firefighting foams also can be sources at Air Force bases and airports nationwide. I'd say, and so those are really the extremes, I think. The highest levels of PFCs in drinking water are found at places like that. But fluorinated chemicals are also found in wastewater, and so septic systems and sewage treatment plants are sources, maybe not at such high levels, but much more commonly throughout the environment. Landfills also can be sources. People throw out their stain-resistant carpets, and then that landfill leachate can pick up some of those PFCs. So at Silent Spring Institute, we've been studying water quality on the Cape for many years. We've been thinking about how chemicals found in wastewater and septic systems and other pollution sources can make their way through the sandy, porous soils of the Cape and end up in drinking water. So we conducted a study in 2010 of emerging contaminants, so fluorinated chemicals, pharmaceuticals, hormones, flame retardants in public drinking water supplies on the Cape. We tested 20 wells for PFOS and PFOA, and we found PFOS was detectable in 8 of the wells that we tested. So this is our detection limit, which is 1 part per trillion. Here's the EPA's provisional health guideline of 200 parts per trillion. And we found some wells that had relatively low levels of PFOS, which could come from septic systems or wastewater treatment plants. But we also found one that was about half the health guideline value, and this was one that was near an airport in an area with a lot of commercial activity. So I pointed out that that there are other pollution sources to be concerned about. This was a well that was has been treated for many years with air stripping to remove volatile organic compounds, but the PFOA and PFOS are not volatile, so that was not an effective treatment for that. We've been told that as a result of this study that the local fire training academy changed their policy to stop using firefighting foams that contain fluorinated chemicals, although recent news shows that that policy may not totally have gone into effect and that there was still these firefighting foams used. We had a follow-up study where we looked at private wells in the Cape that serve about 20% of Cape residents, and we also tested for PFCs. This time we were able to test for more of them. We looked for 14 different fluorinated chemicals. And just to give you a sense, this is just the sum of the concentrations of 5 of the fluorinated chemicals we found. And this is nitrate. And nitrate's a marker for basically wastewater impact. So in more densely developed areas, you have more people, you have more septic systems, you have more nitrate. So this graph shows us that in general, where you have more nitrate, you tend to have higher levels of these fluorinated chemicals. But we did have a couple of wells that stood out for us that didn't seem to follow the trend just based on nitrate. And the goal of the study was not to do a detailed assessment of where the water feeding each well came from, but we think that other sources such as landfill leachate or commercial wastewater could be sources. These are private wells that are just really in residential areas. There's no Air Force base nearby. There's no big source that's visible, and so it's a reminder that in some cases there is like an Air Force base. We know that it's likely to have to lead to groundwater contamination, but there are many smaller sources that are really hard to pinpoint. So the EPA does not require testing for fluorinated chemicals. These are not regulated contaminants, but they did include 6 fluorinated chemicals as part of their most recent monitoring that they do for unregulated contaminants. Basically things that are on their mind that they may eventually, someday, think about regulating, but they want to get a better handle on what the levels are like in drinking water throughout the U.S. So this is called the UCMR3 testing. So all large water suppliers and some smaller water suppliers had to test for 6 PFCs. And 2 of the wells in Hyannis, not ones that we had tested, but nearby, showed up as having PFAS levels above that EPA provisional health advisory. And so as a result of that, they did put in activated carbon treatment to bring the levels of PFCs down in those 2 particular wells. I do want to point out that there are other wells in the Hyannis water system that are still in the top 1% of samples in the U.S. They're not currently being treated because they're not above the health guideline, but kind of a dubious distinction to be in that top 1% of samples. For other communities in Massachusetts, as I said, for the UCMR testing, all large water suppliers and a fraction of small water suppliers did test for 6 of these fluorinated chemicals through the UCMR program. So 165 supplies in Massachusetts were tested, and 5 had detectable levels of fluorinated chemicals. So in addition to Hyannis, we had Danvers, Hudson, Mashpee, and Westfield. I would point out that the tests that they used for the UCMR testing were not very sensitive. So only about 1% of samples tested through the program had detectable levels. But I would point out that that doesn't mean that they aren't there, and that detection limit is basically above where you typically find the range of concentrations where you typically find them throughout the US. So I'm a little worried that people will look at the UCMR data and say, well, it's just in 1% of samples, it's mostly near Air Force spaces, it's just a really local problem, we don't need to regulate it. So I'll be curious to see how those sort of regulations play out, because really that detection limit, I think, is giving us a false impression of the prevalence. And so one question that you have, you say, okay, well, these are in the water, they're at parts per trillion levels, how do we know if we should really be concerned about them? EPA is currently reevaluating its provisional health guidelines, but there's really a lack of consistency. I mean, we know that it's not as simple as there's a bright red line, and if you're above it, you're totally, you have a big problem, and if you're below it, you're totally safe. We know that it's not quite like that, but it's also hard to know which bright red line to look at. So the EPA's provisional health guideline for PFOA has been 400 parts per trillion. Minnesota's is 300. New Jersey's had a guideline of 40. EPA is looking at a new revised guideline of 100. And Vermont just last month came out with a new guideline of 20. So even if we were going to just use a bright red line, it's not really clear which one we would choose. And it's a reminder that our understanding of these chemicals is still evolving. So there's new science coming out all the time. And also scientists can look at the same data and put different weight on different studies, or there's some subjectivity in terms of evaluating what's a level of concern. So I focus mostly on drinking water since that's what I work on, but obviously we're exposed to these chemicals in a lot of other ways, and there's a lot of research right now to really understand what our exposures are from many different pathways in our day-to-day lives. So far the research appears to suggest that if your drinking water is really high, that's probably going to be your biggest source of exposure. If your drinking water is not particularly high in fluorinated chemicals, food appears to be the major source, both from these chemicals getting into soil and water and being taken up by plants or animals, but also from the food packaging. These chemicals can migrate from the food and end up into the food from the food packaging. But there are also other sources. So I have kids and they're running around and they're on the floor and have their hands on the carpet, and then 2 seconds later they're eating a snack. And so I think a lot about what's getting from the products themselves onto our hands. It can be directly ingested. These chemicals can end up in indoor air or in dust. And those exposure pathways, I'd say, are not really well understood at this point, and there's a lot of research to understand that. There was a study of a Canadian family looking at their PFHXS levels, and they were found to be very high in a biomonitoring study. And this was a family that had treated their carpets 8 times in 15 years with, I forget if it was Schaider or Stainmaster. So that's a little extreme in terms of the frequency, but it does definitely show that these products don't just stay in the rug or in your stain-resistant couch. They can lead to exposure. So how can you reduce your exposure? Some tips that we've come up with are to avoid stain-resistant carpets and upholstery. Look for things on labels like perfluoro or polyfluoro or PTFE. Avoiding Teflon cookware and selecting cast iron or enamel cookware. Eating more fresh foods to avoid fast food packaging. Minimizing your contact with ski waxes that contain fluorinated chemicals. And if you have some reason to suspect fluorinated chemicals are in your water, you can filter your water. Activated carbon actually does a really good job at removing fluorinated chemicals. And I guess the basic question is, ask yourself, do I really need this product to have fluorinated chemicals? Is it something I need my waterproof rain pants? I can't live without that. Maybe you can go for that, but you don't need to have a stain-resistant carpet. So just really think about whether you need a product to be fluorinated. And I just want to end with an example from Denmark. So in the US right now, if you buy microwave popcorn, it's likely that packaging contains fluorinated chemicals, because it's hard to make the paper resist the sort of high temperature and the grease of microwaving popcorn. But the largest supplier retailer in Denmark said, we're not going to have harmful chemicals in the products that we sell. And so fluorinated chemicals was on their list of chemicals that they didn't want to have in their products. And they said, we can't actually find any microwave popcorn that doesn't have fluorinated chemicals in the packaging. So I don't think that this would happen in the US, but in Denmark they said, we're not going to sell microwave popcorn. And they didn't have any microwave popcorn until a Spanish packaging company figured out a way to treat their cellulose in a different way. They boiled it longer or something, in a way that they could make it withstand the microwaving process without breaking down. And so now you can get microwave popcorn in Denmark that doesn't have fluorinated chemicals in the packaging. And I think it's a good reminder that regulations can be kind of slow as a way to reduce our exposures, and that a lot of times consumer pressure or even pressure from large manufacturers can change what's in our products. So with that, I just want to point you to our website, silencespring.org, where you can learn all about our research. And we have an online resource called Too Close to Home. And then I recommend you check out our app, Detox Me, and Jessica here in the back can tell you more about that. It's a great way to get some tips for do-it-yourself, formulas for making things in your own home. It's got reward systems and points and badges and gives you all kinds of incentives to make changes in your day-to-day life. Thank you.